Distinguished speaker, my dear colleagues, ladies and gentlemen, a very good morning to all of you. I am pleased to welcome you all on behalf of Gail Training Institute Noida for today's event. I am thankful to all of you for connected virtually for today's program. With me, Dr. R.S. Bhelumurgan, General Manager Training, and Sri P.C. Gupta, Chief Manager, Total Quality Management Department, is present here at GTI. Sakhyam is a significant annual event which is organized jointly by Petroleum Conservation Research Association (PCRA) and the oil industry under the aegis of Ministry of Petroleum and Natural Gas, Government of India, with the sole purpose of bringing awareness among the people on the need for conservation of oil and gas and the means to do it. This year, the campaign is being organized with the theme Green and Clean Energy from 16 January to 15 February 2021. During this period, various activities are carried out in sectors like transport, industrial, agriculture, and household to spread the message on fuel conservation. The campaign will also highlight the adverse health and environmental impacts of increasing the carbon footprints. To celebrate Sakhyam 2021, Gail is organizing a number of events across the country to sensitize citizens on the need for energy conservation. One of such events is talk show and panel discussion, which is being organized by Gail Training Institute Noida in association with Total Quality Management Department, related to the theme of Sakhyam 2021, Green and Clean Energy. So far, Gail Training Institute successfully conducted 4 different talk shows on subject improved domestic cooking burner of PNG, waste plastic for energy conservation. And these both the topics covered by Indian Institute of Petroleum Dehradun. Then role of renewable energy in India's electricity sector in association with Jarmi, Ahmedabad, and prospects of biogas sector in India by Indian Biogas Association. And we have also conducted 4 panel discussions. One is electric vehicle in association with IIT Madras. Second one is role of city gas distribution in clean and green energy by subject matter expert from oil and gas domain. Cultivation of sports in professional life by expert from Sports Academy Association of India. And last topic was on biofuels by subject matter expert from IITM Delhi. In today's panel discussion, we are having Dr. S.C. Sharma, Dr. B. Bhargav, and Dr. B.K. Gupta from IITM Delhi. And the topic for today's panel discussion is hydrogen for automotive using electricity from solar and other green energy. Now I will request Dr. R.S. Bhelumurgan to introduce the faculty and a brief on today's topic. Over to you, sir.
Thank you, Mr. Raji. Welcome and warm good morning to the eminent speaker present here, Dr. S.C. Sharma, Dr. Bhargava, and Dr. V.K. Gupta, colleagues across Gail watching today's webcast, ladies and gentlemen viewing the recorded session of the panel discussion on hydrogen for automotive using electrolysis from solar and other green energy sources. It is my great privilege to introduce today's speakers of this panel discussion. Dr. Sharma is one of the few professionals in the country having worked with the Government of India, PSUs, ONGC, Petronet LNG, and the academic institution like IIT Bombay. His 36 years of career is largely devoted to the growth and development of energy sector in the country. Dr. Sharma has worked extensively on formulation of national energy policies, including market price for energy and oil and gas sectors. He advised Government of India on integration of energy petroleum sector value chain and its economics to develop a sustainable industrial infrastructure. Dr. Sharma prepared a report on India's position on carbon emission sustainability for the country, presents at COP15 in Copenhagen in December 2009. Dr. Sharma had been a member of number of global energy institutions like G20, Clean Energy Ministerial, UN Energy Sustainability Group, and bilateral energy cooperations with OECD countries, including USA, Canada, Australia, and Europe. Let me introduce our second speaker, Dr. Bhargava. He is more than 40 years of experience in energy sector, working in research laboratories, industry, and the government. He is the main architect of National Solar Mission launched in 2010. Currently, he is associated with IITM and other organizations advising on research and other matters. He worked as Director General, ONGC Energy Center. Earlier, he worked in different capacities in the Ministry of New and Renewable Energy, and he was also Director Power Solar Energy Corporation of India. He worked at Central Electronics Limited and National Physical Laboratory, Sagar University, and he holds PhD in physics. During the Director Power, he's worked on the development of various technology, including solar energy, hydrogen fuel cells, so on and so forth. It is pertinent to mention his accomplishment that development of terrestrial solar cell and modular technology for the first time in the country with safe space grade solar cells. Similarly, he worked in enhancement of gas recovery through microbial process, super hydrophobic coatings for solar cells, and thermal splitting of water for hydrogen production. And he also published, he is also having the several national and international standards involved in transfer of technology for manufacture of solar modules. He has written and also published papers in large number of international and national technical journals and conferences in the area of solar PV and hydrogen production. Our moderator of today's panel discussion, I welcome Dr. VK Gupta. He is extensively trained in Japan, has worked for 30 years at top management levels in large MNCs, including CEO, JMAM and JMA Group Japan. He has been providing consulting and training support to several leading Indian and MNCs for past 3 decades. He has been invited as distinguished faculty by IIM, IIT Delhi, ABS and other international universities. He has published over 100 research papers in international journals and conferences. He is advisor and board member of many leading organizations. He has been conferred with several prestigious international awards, and he is also a life member of India Energy Forum. And today's panel discussion is going to cover on the topics like policy framework for use of hydrogen for automotive as initiative for green energy, technical aspects of hydrogen versus batteries for powering vehicles, initiatives and technology for production of hydrogen from renewable energy sources, economic aspects of hydrogen versus conventional fuels for automotive. With this, I am hand over the session to Dr. VK Gupta. Please carry on with session, panel discussion.
Okay. Thank you, Dr. Bhargava and Mr. Mishra ji. I'm very happy that we have with us 2 of my very senior colleagues, Dr. Sharma and Dr. Bhargava. Can you listen to me clearly, sir?
Yeah, that's right.
Are you able to hear me, sir?
Yes.
Thank you, sir. So we'll start with Dr. Sharma, and he was with Planning Commission. So a few questions I have for Dr. Sharma. Why is there so much emphasis being given to hydrogen as a fuel for alternative to petrol and diesel and other fossil fuels? Maybe one can look at the sources, different sources of production for hydrogen. Is hydrogen a competitive fuel with petrol and diesel for transportation? Dr. Sharma, you may take about 25 minutes to address these questions, please.
That's right. Is my presentation visible to everyone now?
It will take a minute, sir. It will come.
Okay, just.
Yes, it is visible to us.
Okay, right. So thank you. Thank you, Dr. Gupta. Thank you, Dr. Gupta, for that that introduction, and basically some of the issues which you have highlighted and the questions which you have asked me, I would be answering through my presentation those questions. But very important thing which is there in favor of hydrogen is that we need to reduce our carbon footprints, and for that only we initiated the work of reducing carbon intensities of GDP by 20 to 20%, 20 to 25% by 2020, and 30 to 35% by 2030. And that has been well documented as per the Paris Agreement. And also now a report has been prepared by Ministry of Environment and Forest to implement these targets. Carbon emissions are some of the major issues for human health and the development of the country. And that's why this mission of hydrogen as a part of green fuel has been taken up by India. Now, what is happening is that we do have a largely transport fuel, industrial fuels are largely carbon or the fossil fuels, and to what extent we could reduce these carbon emitting fuels by the green fuels. And in that context, only hydrogen has been considered. Now, recently, on 1st February, the budget 2021 has announced to launch a hydrogen mission to make hydrogen an acceptable fuel for various commercial activities. Number of agencies are also working globally to make hydrogen commercially viable fuel and to reduce the cost of production of hydrogen from different sources. Currently, the two sources of hydrogen are there. One is, of course, the electrolysis process to produce hydrogen from water, and the second is, of course, to produce hydrogen from natural gas from naphtha or from naphtha for refining process, as also to produce ammonia and urea. So these are the two major areas for which hydrogen is currently being produced, because 95% of hydrogen today available is from the fossil fuel sources. That's largely gas. We are in the process of making the water electrolysis process also cost effective, so that an abundant amount of hydrogen could be produced to meet the future demand. Now, there are some questions. What's going to be the energy supplies of future? We are talking about renewable energy. We are also talking about hydrogen. We are also talking about oil, coal, gas, and nuclear and many other sources. So even biofuels are also part of good part of fuel supplies today. Now, under all these different supply sources, can hydrogen play a dominant role in future supplies? And which technology can make hydrogen a cost competitive fuel with other supply sources like oil and gas or coal? Reforming technology for hydrogen production from gas is one of the technology, or solar power or RE option for hydrogen production as electricity could be another technology. Which hydrogen is more viable, blue or green? The blue hydrogen is from the fossil fuels or the gas reforming. Green hydrogen is from the solar or renewable energy or electricity for the electrolysis process of hydrogen. So these are the two technologies which are currently under discussion, and let's hope that we make these technologies viable in the coming future, and a lot of work is going on. Now, India's hydrogen mission, as I said, the Union Budget 2021 of India has announced hydrogen energy mission to be launched during this year, 2021-22. At RE Invest conference in November 2020, PM had announced to launch a comprehensive national hydrogen mission, and the efforts are being made to produce hydrogen energy from different sources, including green energy. Green hydrogen mission is essential to decarbonize mobility, heavy industries like steel and cement. Hydrogen can be produced from many other sources like bioenergy also, but emphasis is currently being made to produce hydrogen from renewable electricity sources using water electrolysis process. Now, need for hydrogen, 80% of current fuel supplies is from the carbon emitting fuels. And obviously, I mean, with that kind of carbon emitting fuel use, the carbon emissions have grown. In fact, if we have a look at 2019 or 2018, the growth of carbon emissions had been around 3 to 4%, and we need to reduce these growth to zero level. If we want to reach a carbon neutral future by 2020, we have to reduce our carbon emissions by about 7% every year till 2030 to have a better, less carbon atmosphere. The Paris Agreement mandated to reduce emissions or emission intensities of GDP or economy to minimize carbon footprints. And in fact, reduction of emission intensities of GDP or economy has been mandated for developing countries like India. Hydrogen, being a zero carbon emitting fuel, is being considered as a preferred fuel because it could cater to the transport and other industrial usages. Reducing cost of hydrogen production from the electrolysis process is one of the major consideration for it to make economically viable. Now, there are certain properties, the usages. Yes, hydrogen could be used in vehicle, trains, and all other long-range transport applications, and may compete once its commercial production starts with other carbon-emitting fuels. Hydrogen may also become competitive for the boiler applications and low carbon building heat applications and many other applications. In industrial heating, hydrogen can become viable to decarbonize some of the processes. Low carbon and renewable hydrogen may become competitive with blue hydrogen used for the industry feedstock today as the costs fall and the carbon prices as the carbon prices rise. Now, just give a little. I want to give a little idea that how different is the calorific value advantage in hydrogen. The coal's calorific value kcal per kg is 5,300 kcal, while the hydrogen's calorific value is 34,178 kcal per kg. The diesel, kerosene, or the gasoline's calorific value is around 10,200, 10,500, or 11,500 kcal. So the kind of thermal value hydrogen catches is about 3 times of that of other conventional fuels like diesel and petrol, and about 7 to 8 times of that of coal. So the amount of carbon intensity reduction it would really generate would be enormous. And if this fuel is used, let's say even replacing 25% of carbon emitting fuel, that can really give a huge low carbon future for the nations and the planet as a whole. Now, the growth in global hydrogen production, hydrogen had been produced largely for the refining and ammonia production. And as of 2018, a total amount of about 75 million tons of hydrogen was produced, and majority of it, 95% of it was for the refining and ammonia production. Ammonia basically to produce urea as a fertilizer, and refining basically what happens is that the bottom black residue which remains in the refining process, that basically is used with the process of hydrogen to improve its light distillate yield and to improve the yield of petrol and diesel, so that the refining margins also improve. There are some other technologies which where hydrogen could be produced. Methanol is one, and then direct reduction of iron is also one of the area, and there are a number of other applications where hydrogen is used as a clean flame fuel for different processes. Hydrogen, I mean, this is one of the process. About 75 million tons of hydrogen is produced today from the natural gas or naphtha, which is about 0.5% of the total global energy demand. But yes, this we have to really increase it in a big way. Natural gas is currently the primary source of production of hydrogen by steam reforming process. Steam reforming process is established commercial technology, and of course that's how this is used for both ammonia production as well as the product the light distillate product upgradation and refining process. Now, in fact, what happens is that 90% of the cases, hydrogen production and ammonia production, as well as the refining process, hydrogen is produced from gas. But wherever in some refineries or ammonia plants, hydrogen is not available, naphtha is used to produce hydrogen and further produce ammonia and the light distillates. The second is the electrolysis process, including solar electricity. In fact, the electricity is one of the most important ingredient to electrolyze the water to separate the hydrogen at a high temperature. The cost economic plays a major role in deciding the hydrogen production through water electrolysis process. R&D is under progress to reduce the cost of electrolyzer, and number of activities are happening to reduce the cost of electrolyzer and also to improve the efficiency of electrolysis process, which would further make hydrogen a cost-effective. Solar energy being considered as the low-cost energy is also being considered for production of hydrogen through the process of electrolysis. Now, this is one of the slides which gives that what could be the cost of hydrogen production from gas with and without carbon capture and utilization and storage. Now, if we have a look at where the cost of gas is low, like in Russia, United States and Middle East, the cost of gas is much lower compared to the cost of gas in Europe and China, and that's how the cost of production of hydrogen from the natural gas is higher in Europe and China, while in US, Europe and Middle East, the cost of production of hydrogen is comparatively much lower. Now, this is a comparison of hydrogen production. Now, hydrogen production depends on the gas price. If the gas price is, let's say, $2 or $3, hydrogen production cost would be much lower. But if the gas cost is, let's say, $6, $7 or $10 per million BTU, the hydrogen production cost would go up accordingly. Now, this is basically to give a comparative analysis of production of hydrogen from the natural gas with CCUS and with the renewable electricity using the water electrolysis process. Now, the cost of production under the electrolysis process is certainly higher compared to the cost of production from gas to produce hydrogen because the countries like Middle East and Russia, they produce gas at a much lower prices. Also, Australia produces at much lower prices. That's why the cost of production is much lower. But yes, the electrolysis process to produce hydrogen from renewables is yet to be matured, and it's to become more efficient and the cost reduction of electrolyzers to happen. So that's why the costs are somewhat higher. Now, this is some of the roadmap which is being given as to how the cost of hydrogen production could be reduced with different level of electricity charges and with reducing cost of the electrolyzers. Now, the electrolyzers cost capex could be $750 per kilowatt hour, going down to $550 per kilowatt hour to going down to 250 kilowatt hours. The electricity cost also could reduce as we go forward, and the cost of production of hydrogen could range from $5.7 per kg, could go down to as low as $0.6 per kg, and that makes hydrogen production much more competitive compared to the current generation liquid fuels. Now, hydrogen not only needs to be produced, but it also has to be commercially transported to the user sectors, like we transport oil and gas to different areas by pipeline, by tankers, by by railways and all other sources of transportation. Now, at the current level of trucking, the liquid hydrogen or gaseous hydrogen or hydrogen from pipeline, there are a good amount of cost comes, and it is estimated that the transportation cost of hydrogen could be reduced as much as by 60 to 70% by 2030 once the hydrogen becomes commercially viable. Now, these are certain areas the capex could be reduced. Let's say if we have a cost of hydrogen production at $6 per kg, the capex could be reduced by about $1.6. The efficiency could be improved by 0.4 to $0.5. There could be other cost reduction, and energy cost reduction could be around $1.3 to make hydrogen available at $2 per kg kind of price, which could still be higher, but given the kind of carbon emission costs which are coming, carbon emission price which would be developing, would make this cost economically viable. Now, we have developed, India has developed a clean energy project to mix hydrogen with CNG. That is a joint project by the IGL and IOCL. And the pilot project is using hydrogen CNG for as a fuel in 50 BS4 compliant CNG buses of DTC. The Rajghat H-CNG production unit will supply fuel to the 50 CNG buses. This compact reformer will produce 4 tons of hydrogen every day from natural gas, and will and this hydrogen of 4 tons will be blended in a ratio of 18% hydrogen and the balance CNG to run the DTC buses. And this the trial project, and of course it could be further upgraded to a commercial scale as the hydrogen cost reduction takes place. As a concluding remark, yes, hydrogen is a carbon-free clean fuel to achieve carbon neutral future. Lot of work is being done to make hydrogen an economically viable fuel for its use. Reforming technology is certainly well developed and commercially deployed for over last 100 years. Work is under progress to make electrolysis process commercially viable. Creating hydrogen economy is essential for developing a clean and green fuels for the future. And yes, we hope that and we have a belief that yes, hydrogen is a fuel for future as the global economies improve, the money generation improves, the cost efficiencies improve. Yes, the hydrogen is going to become a more viable and affordable clean fuel for the various usages in mobility, transportation, and many other industries, and even as a use in households for cooking, or the households for the lighting purposes. So this hydrogen holds a great future as a clean fuel, and would provide a clean and sustainable future for this generation and next generation once it becomes commercially viable. And we hope that yes, going by the current happenings, yes, hydrogen is going to become a major fuel in future. Thank you. Thank you.
इसका माइक नहीं है। Dr. V.K. Gupta, please unmute your mic. Please.
Thank you, Dr. Sharma. I think it's an excellent overview, and you have given a very comprehensive view of what is already happening and maybe what is in for future. But a lot of assumptions are there, and we are now coming to Dr. Bhargav and make a request to him to give a little insight into the actual implementation part of it. So, a few questions I have for Dr. Bhargav. Is electrolysis the best option for India, especially to produce hydrogen from solar energy? What do you think hydrogen will be cost competitive as a transport fuel? What do you expect from the hydrogen energy mission and the recent announcement made during the current budget? Dr. Bhargav, please.
Thank you, Dr. Gupta, and good afternoon to all colleagues. Basically, this.
You may take about 25 minutes, Dr. Bhargav. About 25 minutes.
This topic has 4 aspects. First, hydrogen to be used as a fuel. That means the other applications of hydrogen and methods to produce hydrogen for other applications that need to be separated. Second is the automotive use. So there you have to see that how today's automobiles need to be redesigned or modified so that hydrogen can be used as a fuel. Third part is electrolysis process for production. Whether the conventional electrolysis process for production of hydrogen is best suited for hydrogen as a fuel or that needs to be modified. Fourth one is solar energy to provide energy or electricity. Do we have other options or solar energy is the better choice? Now, look at this. I need not go into the details of this as Dr. Sharma has already gone through this. The only point I would like to emphasize here is, as the society has developed over the decades, the carbon footprint is reducing. We started with fuel woods, coal, oil and gas, renewables. So eventually we may have to go for hydrogen as a natural choice with zero carbon footprint. Dr. Sharma has already talked about this. So all I would like to say is that hydrogen demand is large and it is growing rapidly. Details have already been shared. Now look at this. Various methods for hydrogen production and its application, they are listed here. Key point is there are 2 methods, one which use heat and other which use electricity. Heat is the one which is today already in commercial use on a large scale. So electricity is the other option where we have to see what can be done, especially when renewable energy sources have been developed and costs have dropped down to a level that using renewable electricity is more attractive than conventional electricity. And that's why electrolysis process for production of hydrogen, that is being talked about. Now this is the process where electricity is split into water and hydrogen. Electrolyzer is used to perform this process. Basically, there are 3 major types of electrolyzers: PEM, alkaline, and solid oxide. What are they? Polymer electrolytic membrane electrolyzers. In this, electrolyzer is a solid specialty polymeric material. Now, this is a key component which is used in these electrolyzers. Water reacts at the anode to form oxygen and positively charged hydrogen ions, which is protons. Electricity flows through an external circuit and hydrogen ions selectively move across the PEM to the cathode. And you can see at the cathode, a reaction takes place. Now this reaction takes place at about 70 to 90 degrees Celsius. And the efficiency of the system could be as high as 80%. Now, depending upon the quality of the stacks and the system, the efficiency keeps varying. The other one is the alkaline electrolyzers. Now, this is the one which is commercially available and widely used. In this, you can see the alkaline electrolytes operate via transport of hydroxide oil through the electrolyte from the cathode to the anode, with hydrogen being generated on the cathode side. This uses a liquid alkaline solution as the electrolyte. And this process is commercially available for several decades. But here, if you can see, the temperature of the process is relatively high, about 150 degrees C. And the efficiency is relatively lower, so up to 70 degrees C. The third one, if you see, which is another emerging option, which is reverse of a solid oxide fuel cell, that is solid oxide electrolyzers. This is a high temperature process, uses solid ceramic materials. This is the process which is still under development. Today, the efficiency of this process is about 50 to 60, and it is performed at temperatures like 700 to 800 degrees C. This uses natural gas as the input fuel, but in this case, the efficiency could go higher than 80% also. And that is the reason that this process is also being looked into. And here also, you know, water is split into hydrogen gas and oxygen. This is, I just shown off a picture of a electrolysis plant in Japan where solar power is being used for the process. So, you know, the topic which we started with, using solar energy to produce hydrogen, that is depicted here. Now, look at this pie chart. Today, roughly about 4% of hydrogen is being produced by electrolysis. Largely the natural gas that dominates. But the future projections are that by 2050, about 22% of hydrogen will be produced by electrolysis, 8% by biogas, which is missing in the first chart, and rest will be from natural gas and coal. Oil refineries, their direct contribution to produce hydrogen, that may go away. Now, why electrolysis for hydrogen production? You see, when electricity produces from hydrogen, renewables is available, hydrogen becomes a carrier of renewable energy, complementary to electricity. Electrolyzers can integrate variable energy sources into power system. You see, one of the limitations for feeding power to the grid for a renewable source of energy is that the power is not dispatchable. This can happen. So when you are using hydrogen as a source, it can be used as a source of storage of renewable energy. It can provide grid balancing, which otherwise is not feasible. So hydrogen from renewables is useful as a storage. It can be used as a transport mechanism for renewable. So electrolysis process for hydrogen production using renewables makes a lot of sense. And especially in the Indian context, when we have set up a target of 175 gigawatt by 2022 and 350 plus by 2030, the amount of renewable energy power which you will be producing, there will be a big issue in dispatching that power and loading that power to the grid. So if that power, when electricity is not used, is used to produce hydrogen, it can be transported, it can be stored, it can be used for grid balancing. So it will provide a stable grid to the country. Now, what have we done as a country in the area of hydrogen energy? You see, we started initial R&D as early as in 70s, where the focus was primarily in the academic institutions. But in later part of 90s, efforts were initiated to demonstrate the application of hydrogen. That whatever hydrogen was available as a bottled hydrogen in cylinders or in refineries, etc., that was used. And we started work on hydrogen generation, storage, fuel cells and application in vehicles, etc. As well as, generator set being run by hydrogen. In early 2000s, these efforts are further strengthened. And that's where, oil and gas companies, they also started working in this. IOCL was the first oil and gas company which started working into this in early 2000s. In fact, at that time, IOCL was the only company which had a full-fledged R&D center to work on alternatives also, other than the research for the oil sector. So that's where they got roped into this. And the ministry, MNRE, in 2003-04, further decided to strengthen these efforts, where we thought in the ministry that the time has come that other than academic institution, industry must also be involved. Because if hydrogen is to be used in the automotive sector, you can't work without industry. If hydrogen is to be used as a fuel and it has to be transported and dispensed with, like fuel dispensing, oil marketing companies, they cannot be ignored. So any integrated development that requires involvement of these sectors of industry, which are really infrastructure sectors. And with that idea in mind, MNRE decided to set up a hydrogen energy board in 2003-04. And at that time I was working on this, and I had the privilege to sign the first order of setting up of the board. As a part of the board, 4 components are there: hydrogen production, hydrogen storage, transportation and applications. So the board decided to set up a steering committee that was under the chairmanship of Mr. Ratan Tata and Mr. Anand Mahendra. They were requested to come out with a working report which essentially led to the hydrogen energy roadmap for India. But the main advantage of that steering group was the industry started thinking right at that time that there is a need to create the ecosystem, to create the infrastructure, and what we popularly call as hydrogen economy. The foundation stone of hydrogen economy in India that was based at that time. And as a result of the efforts and the iteration over the years, in 2006, MNRE released the hydrogen energy roadmap. And that further spurred the activities. So like, after MNRE, I was heading ONGC Energy Center. Energy Center started working on thermochemical splitting of water as early as in 2007, based on the initiatives taken by MNRE at that time. Finally, as a result of the cumulative efforts, this year in the budget, now government has announced launching of the mission this year, though this work is going on for quite some time. Now look at the spectrum of organizations which are working in India into this area. There are large number of academic institutions. Virtually every IIT is there. BHU, ICT, Pune University, ISC Bangalore, several NITs, Jawaharlal Nehru Technical University. Then very large number of government labs and private research institutions. They are also working in this. PARC is one of the lead organizations. Various CSIR labs, ONGC Energy Center where I was working, ARCI, NICE, this National Solar Energy Research Institute, Jawaharlal Nehru Center for Advanced Scientific Research, where Professor C.N.R. Rao is working on splitting of water using photocatalytic methods. Then in the private sector, Space Science Foundation, they are working. They started working in early 2000s. Then if you look at the industry side, Indian Oil, Tata Motors, Mahindra, Ashok Leyland, Bajaj, BHEL, BPCL, Reva, REIL, Gail, all of them they are working. Various government departments and ministries, MNRE, DST, MOPNG, DRDO, DAE, they are all working. Look at that. In early 90s, there were 10 institutions which are working. Now today we have more than 100 institutions in the country which are working in this area. Now, what are the challenges? If we really want hydrogen economy to be developed for India, first and foremost is cost-effective hydrogen production, which Dr. Sharma has extensively dealt in his presentation, and Dr. Gupta had also asked me to talk about. We'll touch about this. Then what are the alternatives to electrolysis? Especially when electrolytic process is becoming more and more efficient and cost of electricity by renewables is declining. So like most of you may be aware that in India, now solar power is available at 2 rupees per kilowatt hour, which is competitive to electricity cost in most of the countries elsewhere. Then what are the alternatives to solar PV? Wind is there, bioenergy is there, hybrid of wind and solar PV is there, then solar thermal power is there. Compact and portable hydrogen storage. Because hydrogen being a very light gas, 1 kg of hydrogen is little over 11.2 meter cube. So that needs to be compressed quite a bit. So how are we going to deal with it? This is also one of the challenges. Fuel transportation and dispensing. If we produce centralized hydrogen, transportation is an issue. And dispensing is anyway required if we need to fill up the tank of a vehicle. Then, when we talk of vehicle, fuel efficient and cost effective vehicles, they are also required. A lot of work is being done and needs to be done. For a country like India, where we have a very large population of vehicles, including two-wheelers, which run on IC-CNG, to talk about the electric drive alone is not economically feasible. So we need to consider ways and means to use hydrogen into IC engine also. Then of course, related safety issues. Hydrogen is a gas. When it burns, you can't see it. So you need to have better codes and standards to ensure such safeties. Now when we talk about alternatives, as I mentioned earlier, thermochemical splitting of water for hydrogen production is one method, where what you do is you use chemical processes at elevated temperatures, 500 degrees C to 800 degrees C, to produce hydrogen and oxygen. The advantage of this process is that hydrogen is produced as a pressurized gas. So some of the investment which is required for compression of hydrogen, that is also taken care by this process. Now I'll show you some of the pictures of one of the research plants which have been developed in the country for producing hydrogen by this method. This plant is set up at Institute of Chemical Technology, Mumbai, and this is running there for last 3 years now. And we have several international patents on this. You see, the other alternative which is attractive, and if you recall, in one of the slides I showed earlier, that 8% hydrogen production could be biological. So biohydrogen, this is one of the other options. This is one of the plants which has been set up at IIT Kharagpur. So coming back to electrolysis, Capital cost reduction, improving the efficiency, these are the two key challenges. And thirdly, as I said a little while ago, integration compression into electrolyzer to avoid the cost of a separate hydrogen compressor for increasing the pressure of hydrogen storage, that is also another challenge. And we have to go into this. Now, talking about storage, being a very light gas, hydrogen needs to be stored at a high pressure. And in countries like Japan, they have developed technology to store up to 800 bar, whereas in our country, right now it is 300 to 400 bar. Liquid hydrogen that can be stored in cryogenic tanks. This is a standard method, widely used in research labs and space organizations, as well as some of the industries. Now, solid state hydrogen storage, this is a very interesting method of hydrogen storage. Metal hydrides, they are very attractive for this purpose and being researched for several decades now. In our countries, in early 2000s, BHU developed the process and nickel metal hydride, they were developed, but the efficiency of the storage was low. Recently in Germany, Fraunhofer Research Institute, they have developed some magnesium-based hydrides. Now that is claimed to be far more efficient and claimed that the energy storage is 3 times more than the lithium-ion batteries. So that is one technology that needs to be watched. And if that becomes successful on large scale, it gives answer for hydrogen to be used in transport vehicles without going for a dispensing station, like, dispensing of diesel or petrol, etc. Then, of course, hydrogen pipelines. This is another method where our colleagues from Gail, they are the experts. They know how to do it, but it has its own limitations. Now, what I would like to show you is some of the pictures of development in the country. Here you can see a hydrogen motorcycle and three-wheeler. They were developed by BHU in early 2000s, and the range of the motorcycle was 70 kilometers per charge. Storage was metal hydride. This metal hydride used 70 degrees C to release hydrogen. So, fitting that metal hydride canister into the motorcycle, that was a technical challenge. Because if you keep it below the seat, it gets heated up slightly and not very comfortable to the driver. Now the latest one, the magnesium-based storage, that reacts with water and releases hydrogen. So I am really excited to read about this. This is a very recent development, and we must watch that development because that is going to be very good for introducing hydrogen for transport. Now this is, blending of hydrogen in CNG. Theoretically up to 30% hydrogen can be blended, with CNG. But what we have done is, a couple of vehicles were developed in the country where 18% hydrogen was blended and experimented, and it was found that emissions are reduced up to 50% and the overall efficiency is improved, and no significant change in the engine was required. Because if you use a pure hydrogen energy engine, it requires a lot of change and redesigning of the engine. Otherwise, the efficiency of the engine reduces considerably. Now, this is the dispensing system. The first system that was put up at at Faridabad in 2005. Next one was put up in Dwarka in 2009. Now a Larger thing is coming up at Rajghat for buses. Now these are the pictures of the system.
I'll just interrupt Dr. Bhargav.
Yeah,
It's an excellent presentation. So we'll come to this for a minute.
I'm just finishing up.
Yeah.
This is
So
Tata Motors.
yeah, I would like to discuss this in detail if you can later. So just one or two questions with Dr. Sharma. Dr. Sharma, we know that we have seen the way how many years this gas will last. I mean, earlier there were prediction of very short time, and possibility of CNG and other natural gas lasting for a very long time, perhaps 200-300 years is what is predicted. So in that situation, will people not go back to CNG and fossil fuel rather than spending so much money because hydrogen become really viable? I mean, today with a lot of assumptions in the presentation, it come down to very low price, I think $0.6 whatever. The question is to reach that will take a lot of time, and alternatively people have an easy option of using CNG as a clean fuel. So what is your view on this, sir?
Well, if we have a look at in order of high carbon intensity, we have to first remove coal from the system. The second fuel which is to be removed from the system is oil. And the third is, of course, the natural gas. Now, natural gas being a lighter fuel, also having a very high hydrogen content, could be used to produce hydrogen, as mentioned in Dr. Bhargav's presentation, that by 2050, if any hydrogen is to be produced, the large quantum, about 35% of hydrogen would come from natural gas. Now, if we have to produce hydrogen from natural gas, the best option is to produce hydrogen from natural gas at the source itself, wherever the gas is produced, there itself. The carbon is extracted, CO2 is extracted from natural gas, and hydrogen is
C2, C4 also you're taking out for petrochemicals perhaps at that stage. You're taking C2 and C5 also.
Yeah, that's right. That's a different process for petrochemical. But if we want to produce hydrogen from natural gas, we have to remove the carbon. That's one carbon, and make it carbon dioxide, and 2H2, the hydrogen, which is removed in the reforming process. Now that's the easiest process and the most cost-effective process is to produce at the source of gas production and to transport it. But you see, what's happening is that cost and prices are mindset. We have lived in an era of $100, $120 per barrel of oil prices, where if tomorrow, let's say next year, oil prices go to $100 per barrel, your entire electrolysis technology could become economically feasible. Now, those are the issues which are under consideration, and as to reduce carbon intensity of emissions is one of the major issues why hydrogen is given.
Thank you, Dr. Sharma. I'll come back to Dr. Bhargav again, because I was in Japan in mid 80s and again mid 90s, and I've seen the development of fuel cell and also experiments using a mixed IC engine using hydrogen at that time. So it is almost 25 years now, and still we are experimenting. So maybe you can give a preview of where are we on the fuel cell, sir? You're just sharing the last few slides, sir. Dr. Bhargav, please.
Yeah, you see, what we have to appreciate is that in the last decade, situation has changed drastically. Now look at the Indian scenario. You talked about CNG. The usage of CNG was marginal unless the Supreme Court of India decided let that be the fuel for transport in a city like Delhi. Now that infrastructure is there, ecosystem is there, costs have declined, safety has improved. Same is going to be in case of hydrogen powered vehicles. Now, as far as the mixing with CNG is concerned, this is essential to create the infrastructure. The gas dispensing stations, CNG, if they mix hydrogen, they are getting sensitized how to handle hydrogen in significant quantities. So this will happen over a period of time.
Yeah, I appreciate it. Thank you very much for that. I think fuel cell was one, perhaps last slide, you can just share that, go back 2 slides back.
Yeah.
But fuel cell is a very promising area, and I think a lot of work has gone into that. That makes it a very compact mechanism for using hydrogen for automotive particularly.
True. See, a lot of work is being done on fuel cells in the country. See, BHEL was the one which set up a 200 kilowatt EAFC fuel cell plant for power generation in 2002. Speak Science Foundation, they started working on TEM fuel cell for electric vehicles as early as in late 90s. Several organizations are working, industry is working. Reva, they developed an electric car and then retrofitted it with fuel cell from Ballards. That was also in early 2000. Now fuel cell bus has been developed by Tata's. IOCL is also involved in that. So basically the ecosystem is developing, but it is slow. So with the launching of National Hydrogen Mission, what will happen? It will accelerate these efforts. Look at solar mission. When solar mission was introduced, 2010 cost of solar power was 17.85 rupees per kilowatt hour. Today it is 2 rupees. So somewhere what you have to do is, you have to start coordinated efforts to develop the infrastructure, set up the target so that volumes are created, and once that happens, cost will start declining. So we are at that stage now.
Okay. Yeah, thank you very much. I think we really had a very comprehensive view of the hydrogen economy and for automotive and other uses. And a lot of development is taking place. Perhaps with this new hydrogen mission, it will speed up, and maybe we can see another 15 years, 10 years, 10 to 15 years time, hydrogen being used extensively like CNG is being used today. I think Dr. Bhargav and Dr. Sharma have been very clear that it will take its own time, and pace will depend on overly the, ultimately end of the day, it has to make business sense to anybody to go in a big way. R&D is okay, but has to make it commercially viable. That's the key point. So thank you very much for both of you, sir. And back to Dr. Gail, please.
Thank you, Dr. Gupta. Now I request Preetham Chand to propose vote of thanks.
Thank you very much, Balu sir. On behalf of Corporate Equipment Department,
Yes.
it is my pleasure to extend vote of thanks on today's panel discussion on hydrogen for automotive using electrolysis from solar and green energy. I would like to express my gratitude and respect to eminent speakers, Dr. S.C. Sharma sir, Dr. B. Bhargav, and Dr. V.K. Gupta from International Institute of Technology and Management, Delhi, for sparing their valuable time and enlightening us with their knowledge, experiences in new era of energy sources, that is mission of hydrogen in India and globe, automotive and industry also for commercial use of commercial vehicles, trains, and long range transport applications, etc. I wish to express my gratitude to Team GTI Noida BIS department to organize this very interesting topic in Sacham 2020-21, which is very much relevant. I also wish to thank everyone who involved directly and indirectly to organize this program. My heartfelt thanks to all GAIL employees who joined this webcast from various sites across GAIL. Once again, thank you very much, sir.
Thank you, sir. Thank you.
Thank you.